Hi. This session will be my last session of the whole set of video. Probably I only made 3 of them. I'm not gonna do anything hardcore today. Basically, I'll do some introduction of historical maths, like for today is prehistoric numeral systems. This is what our ancestors did to count and to calculate. The earliest stage of counting is it was first assisted by using body parts. At the time, the body was an external helpful counting tool, and we call it an artificial memorizing system nowadays, or in abbreviation AMS. Naturally, our ancestors came up with quinary or decimal because they used fingers only. If more body parts were involved, for example toes, the decimal or numeral systems in even larger base number might occur. Well, basically the word quinary here means in a base of 5. I will explain why what is base actually in the last slide, so don't worry. This is base 5, and decimal is base 10, and megasimal is base 20. And another AMS, which came in later, is counting by telemarks, which first appeared in Upper Paleolithic. A common form of telemarks is notched bones, and the numeral symbols are usually clustered in groups of 5. The cluster size of 5 is easy to identify accurately with naked eye, and it is easy to represent numbers in decimal. So basically, a telemark is just those scratches and knots on a stone or on a bone, or we just draw it on the wall of the cave. Roman numerals, the Brahmi and Chinese numerals from 1 to 3, and rod numerals are derived from telemarks. So for example, the Roman ones, we expressed 1 with 1 stick or an eye, and for 2 it's like this, and for 3 is 3 sticks or 3 scratches. And also in Chinese, we have 1, 2, and 3. So these are all derived from those little scratches and those rods we use to memorizing numbers. So here are some pictures about telemarks. Most of them are notched bones, so we can see those scratches around, and we also can see there are some longer ones and there are some shorter ones, but most of them are in groups of 4 or 5. Which means maybe really our ancestors could only count up to 4, and then they add a digit to represent 5, probably. Then after we have been more civilized, and we have a better, more advanced society, the Egyptian numerals occurred. The system of ancient Egyptian numerals was used from around 3000 BCE, well, this is before Christ, until the early first millennium CE. It was a system based on the multiples of 10 written in hieroglyphs. By 20 by By 1740 BCE, the Egyptians had a symbol for 0 in accounting text. They also had a blurred concept of negative numbers, which came from below the base level of tombs or pyramids. Egyptians could also express rational numbers in sums of certain fractions. They wrote them in a form called the Eye of Horus. So here's a chart for the ancient Egyptian numerals. So we can see from 1 to 9, they are probably derived from Telemarks because we can see those rods here. But from 10 on, it'll be a curved line, and then they count up from 10 to 99. And afterwards, for 100, they use a different kind of curly line. So probably their numeral system is in decimal, but I don't know. So here's the Eye of Horus. Ancient Egyptians could not really represent all the rational numbers. They can only represent fractions in a certain form of sum of something. Like if they want to express a sum of a half and a 1/4, they will just write a circle and the right part of the eye. So this means a half plus a quarter. If they want to add more things, they can just draw the other parts separately. Interestingly, even the eye is called the Eye of Horus, but the god Horus is not really the god of intelligence in Egyptian legends. Actually, the god of the Horus god is, I think, if I remember it correctly, he is actually the grandson of the god of sun, Ra, and he is actually the god of revenge. So then later on, the Babylonian civilization came up, and they have their own unique numeral system. It's called Assyro-Chaldean Babylonian cuneiform numerals, which is super long. They were written in cuneiform, of course, using a wedge-tipped reed stylus to make a mark on the soft clay tablet, which would be dried under the sun to create a permanent record. The system is somehow sexagesimal, and it first appeared 2000 BCE. The Babylonians might inherit it from either the Sumerian or the Akkadians. Babylonian system is created for being the first known positional numeral system, in which the value of a digit depends both on the digit itself and its position within the number, just like what we use today. This means if they want more digits, they will add another group of symbols somewhere else to denote, oh, this is another digit. The Babylonians had no concept of 0, but they had an idea of a nothingness. Probably for Babylonians, nothing is not really a number. Nothingness is just nothingness. So these are called cuneiform symbols. So we can see that for inside one digit, amazingly, the Babylonians can actually count up from 1 to 59 and then add another digit to denote the new digit for 60. So this is amazing. And it is a bit confusing why Babylonians used a base of 60 to count numbers, and I think that might probably because Babylonians had also they had amazing astrology, so they will count up the period of moons and suns, and that might, and most of the time the days taken for moon to go around the earth is the factor of 60. I think that may be the reason, but I don't know. Okay, another set of numeral systems later on is called Aegean numerals. It is a system used by Minoan and Mycenaean civilizations. They are attested in Linear A, a writing system of Minoans, and Linear B, a writing system for Mycenaeans. Aegean numerals occurred roughly from 1800 to 1200 BCE. So the Aegean numerals look similar with the Babylonian numerals, but they are more likely to be decimal instead of a base of 60. But still, they are using different marks and symbols once it counts up to 10 in one digit. It's like we use vertical lines for 1 to 9, and then for 10 we use horizontal lines, and then for 100 we use a little circle, and for 1,000 we use a circle and a cross, and they can count up even to this large, 19,000. And then I'm gonna introduce the Mayan numerals. The Mayan numeral system is the system to represent numbers and calendar days in Maya civilization. The numerals are made up of 3 symbols: a shell for 0, a dot for 1, and a bar for 5. It appeared around 36 BCE, and it is also a positional system. The larger digit is written above the smaller one in base 20. That is a decimal. So in Mayan numerals, in a single digit, we count up from 1 to 19, and then we add a dot to denote there is 120, and then there is 0, so it's 20, and for 21 is 120 here and a 1 here, so it's 21. And then afterwards, the rules are basically the same. So this is the calendar for Mayan people. And they're not going to use the simple version for numbers in their complicated, dedicated calendar. They're actually using drawings. They're actually using the faces of different gods for each month. Okay, last part. This may be the most important part of this session. because finally I'm gonna explain what is the base of numerals, what is the base of number. And it is a bit hard to just explain it by words, so I'm gonna do it by giving some examples and a question. For example, a decimal, a base 10 number of 10010 means we have 1 times 10 to the power of 4, which means 10 times 10 times 10 times 10. We times 10 for 4 times. And then we have 0 of 10 to the power of 3. And then we have no 10 to the power of 2. And then we have a 10 to the power of 1, which is 10. And then we have no 10 to the power of 0. However, by definition, any number to the power of 0 equals 1. And this is what it means in base 10. And a binary number of 10010 means we have a 2 to the power of 4, and we have no 2 to the power of 3, and we have no 2 to the power of 2, and we have a 2 to the power of 1, and we have no 2 to the power of 0, which means you will get 16 plus 0 plus 0 plus 2 plus 0, and it gives you 18 in decimal. Now I'm gonna ask you a question. What is the base 20 and number 25? Well, what is number 25 in base 20 means in decimal? And I hope you can pause here and think for a while. Or probably if you don't want to pause, I can just leave it there for maybe 2 minutes. Alright, I think that will do. And if you still don't know the answer, I really recommend you to stop there and leave this video and think for a while, maybe as homework, until you got something. Or if you really don't want to think anymore, just keep listening. Well, for 25 in under a base of 20, you will know that the second digit is 20. The second digit means 2. There are 2 times 20 to the power of 1, right? And then plus 5 times 20 to the power of 0. So then you will get a 40 plus 5. So it's 45. And alright, I think I just finished my last session, and it's a bit short because I don't know. Last time I tried, I reached half an hour, but this time I didn't. I don't know why. I really tried it several times, okay? Anyway, hopefully you learned something from it, and hopefully it's an interesting session for you. Bye.